Thank you very much. Can you hear me?
Yes.
Yes,
Yes, I can
great.
hear
Thank
you.
you.
I can see your slides. Everything works perfectly.
Perfectly. Great. Thank you. Thank you for the kind introduction. It is my pleasure to talk to you today with the title of my talk, Phase Transition and AI. I know that today's schedule is filled with different talks talking about latest AI advances, including different applications of AI technologies in the world. Today, at this talk, I will try to give a higher level perspective into the latest changes we have seen with generative AI models like GPT-4 and ChatGPT, discuss why these models, in my opinion, mean a significant phase transition in the way we deploy and build AI systems, and also discuss consequences of this technology for our society and make some predictions about the future directions. As many of you know, AI technologies are not new to our society. There has been many applications of AI systems in the world, including search engines to the different speech recognition technology you use on your phones. What is really new about this new phase in AI is that we are transitioning from narrow AI systems that is carefully trained and developed for a particular application in mind to general AI systems where one model or a family of models can actually empower people across different tasks, contexts, and goals. And I'm sure you heard about ChatGPT, GPT-4, BART, named models this year. I actually use this general AI terminology to refer to many AI models that took the world by storm in the last year. And this is actually not a big surprise for people who have been working in this space, and many of you are joining by giving your talks in your conference today. And to kind of talk about where these models came from, I want to take you to 2018, where we started seeing a trend in the machine learning community. This trend was about using unsupervised learning techniques on very large data sets to be able to train models as large as possible. On this graph shown here, the x-axis is dates ranging from 2018 to 2021, and y-axis shows on the exponential scale, the number of parameters these models have been growing from different industry and academic partners. These models use this common architecture called transformers, and the main learning signal used in this training is expert prediction. And this works well because with this learning signal, it can process large data sets, mainly coming from the internet, and teach itself how to process text as a main representation of the world that we live in. And the trend we were seeing here is that as these models got larger and larger, the hope was that the benefits we see from these larger models would not be diminishing. And in fact, of course, we did not know where this trend would take us. But this is another look into this kind of the evolution of the models coming from 2018 all the way to 2023, just to show how both open source community and the closed source models we have across different organizations have evolved, built almost like a family tree of models getting larger and larger and more capable in time. Just to discuss one particular data point to explain why I believe this is a phase transition, I want to go back again the development of GPT-3 by OpenAI. When this GPT-3 paper came out and shared with the academic community, this graph in particular took my attention with many of my colleagues. What this graph was showing was that in the x-axis, we were looking at models that were getting larger and larger. On the y-axis, we were seeing the performance of the model, the GPT-3 model, when it was used in zero shot, where it was only a prompt without seeing any examples. With the green, it was seeing a single example, and on the orange, it was only seeing a few examples. The interesting thing is that the model that received a prompt was actually, without seeing any examples, was getting as close as possible to the narrow AI model, the fine-tuned SOTA model, that knew a lot about this particular task of trivia Q&A. And by only seeing the prompt and few examples, this very general model called GPT-3 for the first time was able to exceed the performance of the fine-tuned SOTA model. Of course, the big unknown was that the kind of results that was shown by these benchmarks and the papers, were they really for real? Do they carry promise for the different real-world systems that we would like to deploy in the world? And in fact, as these models got larger and larger, would their capabilities actually grow with the same scale? And this is the question that came to our door exactly a year ago when we were brought into a particular working group at Microsoft Research with gaining an access to a model that wasn't called GPT-4 back then, but we later learned that it was in fact GPT-4. So our mission here was working closely inside the company to understand what were the opportunities and the risks of this new family of models, and and really understand whether this model carried a big potential or not. It was a very interesting experience for us where a few of us researchers came together on a table every day and started playing this model again called GPT-4 today and try to understand what new capabilities this model exhibited. We later shared our findings with the academic community on a paper called Sparks of Artificial General Intelligence. And this paper was downloaded millions of times in its first week of life. I want to share some examples of the kind of behavior we have seen with this early version of GPT-4. We have seen that we could prompt this model for very interesting different applications that wasn't tried before and see that the model was doing really interesting capabilities. One of the things we tried was prompting the model with the prompt, can you write a proof of infinitude of primes with every line that rhymes? And on its first try, the model came up with the solution. Yes, I think I can, though it might take a clever plan. I'll start by noting Euclid's proof, which shows that primes aren't just aloof. Assume we have a finite list of primes and that none have been missed. Multiply them all together and add one just to be clever. The result will be a number that has no prime factors or wonder. But every number has a prime that divides it is just a matter of time. So we found a contradiction and our finite list needs eviction. So what is really interesting about this example is that not only that the model can actually represent a well-known proof, but it could also do it in a format that was currently did not exist on the internet, which was writing it in the form of rhymes. We've also tested this model with different programming tasks and saw really interesting performance, including this example where we give specific instructions about the code the model should write, and then actually write also the code to be able to record the execution of the code. The other big jump that we have seen with this new model was its planning and reasoning capabilities. When we asked the model, it kind of gave a puzzle that did not exist on the internet, where we say, you have a book, 9 eggs, a laptop, a bottle, and a nail. Please tell me how to stack them onto each other in a stable manner. We actually saw that the model had some understanding of the physics that can govern these different objects and come up with a sequential plan that could more stably stack them together than alternative approaches. But I want to show a few examples that really hints that these models can be really useful in building AI applications as well. One of such examples is coming from the theory of mind literature, where we give a puzzle to this model to be able to assess what different actors in the story knows about each other. And surprisingly, the model was able to really build this map of theory of mind, building on a map of what each actor knows about each other, given that they have different observations about the world. This theory of mind has been proposed as a challenge for different machine learning models in the past, and we are seeing a particularly interesting jump in terms of the model's capabilities to be able to answer these theory of mind questions. The other interesting challenge we tried is posing some human scenarios to this model, GPT-4 model, and watch the model reasoning about some human scenarios. In this conversation, what you will see is a conversation between two parents arguing about their child's behavior, a scenario that's pretty common to many parents in the room. And in this scenario, we can actually ask the model questions around how one individual feels about the situation. And here the response actually gives us hints of simulating empathy, where the model can say that this person feels angry and frustrated with how the husband here reacted to the son's behavior. She thinks that Mark is too soft and he is defending the son instead of teaching him a lesson. She wants to be responsible and a strict mother, but she also feels hurt by the husband's criticism of the parenting side. And moreover, when we actually ask the model, how would you coach this person to be able to resolve the situation with the husband, we can actually see that the model can compose in this scenario a pretty empathetic response, thinking about remember that you and the husband are partners, you want the same thing for your family. By cooperating and communicating calmly, you can create a more peaceful and loving environment for your children. So again, we are seeing the first hints that such models can now process different human situations and be able to uh, perform and function in a way that can actually provide a response that may perceive empathetic to a human being. Now I want to change course a little bit and discuss what these models mean in terms of the future of computing and the computing architectures that we are seeing in the industry. One of the most important developments is that the fact that these models can perform tasks by just following a natural language prompt, that means that the way we program these systems is fundamentally changing. Instead of people coding these systems, now we are seeing the natural language being the new programming paradigm. And not only that without a significant background in computer science or artificial intelligence, people can build some AI systems and deploy them in the world, which mean a lower bar in expertise and effort. But this is not only about being able to build and deploy these systems easily, but also the fact that the way systems are going to be built in the future are going to look very different than today. The community that is really thinking about this AI stack that has these large language models at its center and then building components around it, we are really in the process of reinventing the von Neumann architecture for future systems, such that now the CPU is really this large language model at the heart and being able to empower different applications by working with different components around it. So at the heart of it, we have the large language models, but around it, we need to figure out how we represent memory, how we think about different policies, and most importantly, have representation of the world and the individuals and enable some personalization. Since the slide actually in 2023, we've already seen different architectures being proposed, including multi-agent architectures that can do very sophisticated orchestration of the models, really leading to even advancing the AI capabilities further, like the AutoGen libraries. Another interesting development is that as people are building new applications using these models at the center, in these new applications, the way we interact with the technology is inherently different. For example, coming from Microsoft, I get to observe a lot of the work happening around building different Copilot scenarios where these systems enabled by these large language models can be used to, in these Copilot scenarios, can be used to assist people using Word, Office, Excel, and different productivity softwares. And here, for example, showing a particular example of a Copilot in Word assisting people. Here, instead of doing simple tasks like that, just doing like grammar checks and so forth, now we can give in natural language a task to this Copilot in terms of creating a document, putting ideas together, or being able to summarize a document. And the agent is starting to behave like a collaborator working with the people in these documents and provide a much richer support than what was previously possible. And what is really happening, again, sitting inside Microsoft, is that we are seeing this new technology of LLMs really revising the complete productivity suite that we see. Um, we are seeing these language models being used inside the coding platforms to be able to assist people when they are programming. This is the GitHub Copilot scenario. And then the different the Bing has a new agent, a copilot that can assist people when they are searching for information. The Microsoft 365 copilot is the productivity one. And finally, another one that is actually helping security professionals in terms of protecting their systems against security attacks. These are all different kind of copilot scenarios that are coming to the surface. And even more importantly, the studies that is done on GitHub Copilot shows that having access to these copilots and being able to work with them is fundamentally changing how professionals work. In fact, according to this particular study that was presented in the Artificial Intelligence Index report of 2023, uh, by just using the GitHub Copilot, a programmer can actually double up their productivity. This is such a significant result because, as many of you know, productivity in the world has been pretty stable, not improving in the last 30 years or so. And for the first time in a long while, we are seeing that a technology that uses generative AI can indicate significant shifts in the productivity of knowledge workers. And this is, again, an important part of why we think we are at this phase transition in terms of the integration of generative AI technologies into our society. At the same time, when we see a technology that can have such a significant effect into the way people work, this also brings up a lot of interesting societal questions. Some of them can be alarming. For example, in a world where the productivity of knowledge workers can double up just because they have access to a technology, what does that mean in terms of future employment? If AI tools are going to be so powerful, who will decide who will have access to these tools and how the economy around them is going to work? And in fact, how do we develop and deploy these technologies in a way that this technology does not widen the societal gaps that already exist in the society and can be shared in a fair way? And in fact, we need to pay a lot of attention to the longer term effects on jobs, economy, and the social change by paying a lot of attention to to the concerns around fairness, access, and equity. Talking about the risks, one important consideration is this area that we call responsible AI, which I personally do a lot of work inside Microsoft. Many of you may have seen these letters being signed by some of the leading experts in the world on AI, talking about AI posing risks of extinction or calling for a temporary pause into AI development. And this has been part of the discourse on AI. At Microsoft, we have been working on the different principles of responsible AI since 2016 and actually established processes in terms of thinking about responsible AI. These processes include our responsible AI standard, which is active for any AI product we build in the company. And if you're interested, you can find a copy of our responsible AI standard on the internet. In addition to the different tools, best practices, and documents we have created over the years to be able to guide responsible AI work in the company, and we share with these works with the public. And over time, the processes we have implemented that is used for identifying, diagnosing, and mitigating the issues are currently at use in our current generative AI platforms. For example, in this particular example, you can see the different techniques we have developed for detecting and mitigating hallucinations working in harmony to be able to provide a more reliable and responsible service in Bing. At the same time, one of the topics that is really top of mind for us is not only the risks that come from the imperfections of AI systems, but the risks that can come from the adversarial use of AI systems. We really have to think about a potential future where an adversary can have access to these powerful technologies and can use these technologies to be able to create misinformation campaigns, to be able to manipulate the public or minors or elderly, and even spread lies about science. And we have seen that because these models can have engaging conversations and even can build possibly relationships with people through longer term interactions, such adversarial scenarios have increasingly significant risk. Combine that with deepfakes and image and video generation. Again, it is easy to see why we have to put a lot of attention into responsible AI, because with the different techniques I have shown you in terms of the transformation and the face transformation, in terms of developing AI systems, we have a new tool in our hands with generative AI that is highly approachable, highly general, and highly accessible, that can be used in different adversarial scenarios that includes risks for misinformation, risks to democracy, manipulation, attacks to infrastructure, and attacks to privacy as well. Recognizing this very recently, in fact, just 2 weeks ago, United States White House released their executive order on the safe, secure, and trustworthy development and use of artificial intelligence. And this is a positive step in terms of, again, standardizing existing practices in responsible AI, and hopefully motivating even more thinking and work to be able to address these issues altogether. I want to conclude with a few questions that relate to scientific and technological progress when it comes to this phase transition that we see in AI. There are very interesting questions about characterizing what kind of intelligence that these latest AI systems possess, and also think about the effect of humans in the long term, that working with such AI systems in the longer term, what's going to do to our own intelligence as human beings. I have shown you that these technologies uh, really indicate a disruption for productivity work and for the programming work and so forth. But it is very likely that those disruptions are not going to be limited to office workers, but it's going to also spread to different scientific areas. And it's very likely that we are going to be seeing disruption in those areas as well. And even more importantly, what are the socio-technical work we should be investing in today, such that we are going to be preparing our future generations for a new world where these AI systems are likely to be our partners and co-pilots for many years to come. So thank you very much for your attention, and I hope you have an engaging conference.
Thank you, Eche.